Hopefully that works. All right. Hopefully that will work. All right, we'll wait for just a few minutes here. We'll get people in. Interesting, interesting. Maybe that actually does work. I don't know. I mean, can't hurt. Well, we'll give it a try. Yes. We'll get some people in. This. Hey, Jen, how are you? Hello. How are we doing today? Thank you. I appreciate that. I should have worn it yesterday, but I I didn't think any of that would happen, to be perfectly honest. That was a pretty crazy day yesterday, let me be honest with you. Yep, I'll be starting my online class in, well, when other people start to trickle in. It should be pretty soon. So, but what online class are you taking in about 15 minutes there? A class about comics? Hey, that's pretty good. Sign me up. Maybe that's a little bit more enjoyable than just doing some mathematics. I don't know. You're like, I want a Thanos snap mathematics. I'm like, I totally understand. It's relevant to your class. That's very important. Hello, hello, hello. Ah. Thank you. Yeah, I'll be having three classes here today. So I'll be doing this class, the next one, and one at about 4 o'clock at least Central Time. So yeah, I'll be definitely here. You have a wonderful class, okay, Jan? All right, we'll wait for a few more people here for a couple more minutes, and then we'll go ahead and get started here with today's lesson. Yeah, let's do this. There we go. Got a few more people coming in. Good, 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 good. Very good. Let's at least put that out there. Good morning, Alyssa. How are you? I have a good feeling about today. I don't know what it is, but I have a pretty good feeling about today. Today's Today just feels good. Today just feels good, everybody. I'm sensing a lot of positive vibes today. A lot of positive vibes. I'm doing very well. Very well, Alyssa. The positive vibes are real. They're real. I promise you that. Positive vibes is a positive mind. You got that right, K Dog. You definitely got that right, my friend. Absolutely. Gotta gotta keep focused, gotta keep positive. That's what we're here to do. That's what we're here to do. We're like, I don't know, just feels that got that little tingle there. You just kind of feel that it's gonna be a good day today for some reason. And I'll take that feeling any day of the week. All right. Let's think we got enough people here. Hopefully, a few more people will join us here in just a little bit. But let's go ahead and get started. All right. So, okay, let's get started today. Welcome back to Thursday. All right. End of the week time today. Well, we didn't meet on Tuesday, unfortunately. I know that was election day, and well, both colleges, actually, Elgin and Harper, both said, "Hey, yeah, election day is a holiday, so we'll be conducting no classes." But hopefully, you went out and voted and did your thing. You know, had a nice, relaxing Tuesday at the very least. You know, got a nice chance to chill out a little bit. But today, let's talk about what we're going to be doing here today. Today, we're going to be moving on here from where we left off last time. Now, last time we talked about ratios and proportions. Okay, we did talk about that to some. We talked about ratios here. We haven't talked about proportions yet, and we're going to talk about that here. And we're going to today, pretty much for the whole class, we're going to be working with proportions here in some capacity. All right. Pretty much the rest of chapter 5 here is going to deal with proportions. We're going to talk about what a proportion is. We're going to be able to solve for something within a proportion, and then the last section, which I know we won't get to today, but what will come for next class there is like, say, word problems with proportions. Now, just to give you a little bit of a heads up here, once we're done with chapter 5, chapters 4 and 5 there will consist of a test, okay? So we're not quite done here with chapter 5 yet. Once we get done with chapter 5, I'll then post a test there for chapters 4, the 4 and 5 test, and get that ready to go. Okay, so that's what's on the agenda here moving forward. Of course, I'll always give you a warning ahead of time, so that way you're prepared and ready to go. All right, so uh, that is that is what we have going on there so far. So easy peasy, I promise you that. Okay, really quick here, does anybody have any questions about anything um, over the past week before we move forward? No? Okay. Just let me know if you do have any questions, then I'll certainly answer them for you. Okay. So let's go ahead and move on here with the new stuff here for today. We're going to do sections 5.3 and 5.4. That's what so if you want sections for homework here, sections 5.3 and 5.4 are what are on the docket here for today. Okay, so today we're going to be talking about proportions. Okay, so now proportions here is basically like saying, okay, if I have, say, three, uh, I guess I could put it this way. Proportions are basically like ratios. Again, as we talked about last time, ratios here is just like we have 1 part sugar to 3 parts water. Well, what would happen if we scaled it up? So let's say instead of just a cake for ourselves or like a sheet of brownies, maybe I want to cook more brownies at once. Well, okay, well, I'm going to need to add more sugar and more water. Well, what happens if instead I want to make from 20 brownies to, say, 50 brownies? How much of those ingredients do I have to put in? Well, I need to do that via proportion, okay? Again, the original recipe called for, say, 1 cup of sugar for those first 20 brownies. Well, how many cups of sugar should I put for 50 brownies? All right, that's essentially what a proportion is going to tell you. Now, the first thing that we want to focus on here is writing out the proportion based on the words. As we've talked about before, we've talked about, again, interpreting the words here appropriately and being able to write out a proportion. Now, and, writing out a ratio, I should say. Now, let's talk about each part here. So let's look at this here, and we'll talk about the key here in this case, in each case. So, all right. Now, let's where we got this, okay. Okay. So, what is the key here to help write out the proportion here? The key essentially is to line up your respective units. Okay, it's to line up your respective units is to write a proportion out. Now you're probably saying, well, hold up a second. What exactly does that mean? All right. What do you mean by lining up your respective units? That seems very, seems very general. Let's take a look at this first example here. This is on page 193 on your handout there. Now it says 6 feet is to 11 feet. Now you're probably saying, well, what does that mean? Okay, now in general, a proportion is going to look like this. It'll have, say, in general, it'll be like an A over B equals some C over D. But what we want to look at here specifically is we want to look at exactly what this interprets and where we can place A, B, C, and D here, respectively. So it says 6 feet is to 11 feet. Now let's not forget what is means. Is means equals. We talked about that before, all right? We talk about, say, you could talk about percentages here. Is means like equals here. So I could say 6 feet is to 11 feet. Okay, so 6 feet is to 11 feet. Now, since I have to write proportions as kind of two fractions, I can put this over something. And as you can see here, as here, again, separates the two fractions here. So this is kind of like your two things. So 6 goes to 11, and 18 is to 33. So I have 18 feet, and I have 33 feet. So they basically line up your respective units. 18 lines up with 33, and 6 lines up with 11. Okay, so you can see exactly how that works out for an example like this. Okay, now maybe that wasn't super clear, and I totally understand. I'm not going to disagree with you. Let's take a look at the next one, okay, and let's see if we can work that out together. So it says $9 is to 6 liters as $3 is to 2 liters. Now let's set up our equal sign here in the middle. Just put some fraction guys here, no problem. So it says $9 is to 6 liters. Okay. So here's what we're going to do. Again, we're just going to line up our respective units. So dollars to liters should line up all together, be on the same same like line per se. So we have $9 here, and we have 6 liters here. What should I put on the bottom here? It says $3 is to 2 liters. Should I put underneath the 9? Should I put a 3 or should I put a 2? What should I put underneath the 9 here? Okay, that's correct. The $3, right? Exactly. Good. That's correct. I need to put the $3 there underneath the 9. And then for 6 liters, I'm going to put 2 liters. So take a look. Let's look at the answer here, okay? Just writing the proportion out, okay? Let's just look at the answer here. So we have, again, $9 lines up with 6 liters, again, on just two opposite sides. And $3 lines up with 2 liters just on opposite sides as well. So you can see exactly how that works out there in that case. Okay. All right. Let's have you give a try here. We'll take a short minute here. Won't take too long. Let me want you to try letter A. Okay. In fractional format with the equal sign, how would you write this first proportion out? $7 is to 3 cans, as $28 is to 12 cans. How would we write that in proportional language? I'll give you like 30 seconds to kind of write that out. Once you got an answer there, go ahead and type it out in chat. Okay, both of those answers that you see there are absolutely correct. Alyssa, don't forget about the equal sign in the middle there, but I think I know what you meant there. So, but that is correct nonetheless. So you have $7 goes to, again, 3 cans, right? And we have $28 goes to 12 cans. Good. That is correct. Excellent. Nice job, everybody. All right. So far, so bueno. Okay. Now this is going to be important here, especially for what we're going to be doing here for the next section. So again, setting up these problems here are going to be pretty incredibly important. Okay. Now, let's take a good look here at the next part, which is writing the ratios in lowest terms. Now, we can determine whether the ratios are equal to each other or not. Remember, there is that equal sign there in the middle of our particular ratios. And one way to determine if two ratios are equal to each other is if we just kind of, again, just pare down the fraction. Again, write each fraction that we have on both the left-hand side and right-hand side in lowest terms. So that was just, again, lowest terms, meaning, hey, we're going to divide that same number on the numerator and denominator, and then we're going to just keep paring it down until we get and go no further. So let's take a look here and see how we can go ahead and attack some of these problems here. All right, so here we have 5 over 9 equals 18 over 27. All right, now let's take a look at 5 over 9 here first. Now, unfortunately for us, 5 and 9 don't really share a common factor. Unfortunately, we can't divide the numerator and denominator by any number to reduce that down. So we're just going to leave 5 over 9 alone. 18 over 27, though, yeah, I think that's doable. All right, so can anybody tell me here, what can I divide the numerator and denominator by? How can I reduce 18 over 27? What should I divide by here? What do you think is a good idea? 9. That's right, Ola. All right. Now, if you didn't see that right away, that's fine. You could have picked 3, and then you would have done 3 again to reduce it down. But 9 is certainly true as well. So what do we get here? We get 18 divided by 9 and 27 divided by 9. What do we get here as a fraction after reducing it down? 2/3. Okay, good. Now all we have to say is this true or false? Well, is 5/9 equal 5/9 equals 2/3? Well, I think we can safely say no, they're not the same. So this is going to be false, okay? If these ratios were indeed equal to each other, then these would be exactly the same after reducing it all the way down. So unfortunately, we tried to reduce and we didn't get 5/9, we instead got 2/3, which doesn't match what we had in the beginning on the left-hand side. So left-hand side definitely not equal to the right-hand side. All right, let's try the next one. 16 over 12 and 28 over 21. Okay, let's do 16 over 12 here first. All right, what can we divide by here? In this case, to reduce it down, if we can. 16 and 12, what can we divide by here, if any number, that can help us reduce this fraction down? All right, nice. That's right, Alyssa, 4. Okay, good, good, good. So we're going to divide by 4 here. So if we divide both the numerator and denominator here by 4, get 16 divided by 4 and 12 divided by 4 here. What is going to be our fraction here on the left-hand side? What are we going to get? 4/3. Good. Nice. Okay. So far, so good. Alrighty. Not too hard. Okay, so far, so good. Okay. let's look at the next one here. So we got 28 over 21, okay? And so let's see what we can do here. If we can reduce this down, what could we divide the numerator and denominator by to get it down to smaller numbers there? And what can we do there? We can divide by the numerator and denominator by. 28 and 21 maybe have a number in common. Hmm. So I'll let you guys tell me. 7. 7 is correct. Very good. All right, so 7 is spot on. I agree with that. Okay. So let's take a look here. We have 28 divided by 7 and 21 divided by 7. All right. And what do we get here for our fraction after reducing it down? We have 28 divided by 7 and 21 divided by 7. Hmm. All right. List for 4/3. Good. That's right. So we have 4/3 for the first fraction. We got 4/3 for the second fraction. So we have 4/3 equals 4/3. Well, that's definitely true. So this definitely works out the way we want it to. So, okay. We've now confirmed that these two particular fractions, these two particular proportions are indeed equal to each other. Okay. Now, let's have you guys give it a try. All right, so I'm just going to have you do just one of these. It's not supposed to be super hard. All right, let's have you try. Yeah, let's have you try letter C. So let's have you guys try letter C here. All right, let's take a minute or so. Again, if you do say it's true or false, okay, and we'll take a look at if it is true or false by reducing this fraction. So when you have an answer there, go ahead and post that in the chat, and then we'll do it together. So let's take a minute and try. Okay. So all I'm looking for here is true or false for this. I know what you're trying to do here, Alyssa. Like I see what you're saying. We just want like say true or false. Actually, really quick question here: is the chat very laggy? I guess is the question. Like the stream is okay, but I don't know if the chat's super laggy. All right. Well, let's take a look and see what you guys found out. Okay. So here we have 35 over 45. Now, as was correctly stated, dividing by 5 is certainly a good idea. So let's divide by 5 on both the numerator and denominator here. So we have 35 divided by 5, which is 7. 45 divided by 5, which is 9. So our first one here is 7 over 9. Next we have 12 over 18. Here we're going to go ahead and divide by, in this case here, 3. No, actually 6. Actually, we could choose 6. So we can just divide by 6. And so here we get 12 by 6 is 2, and we get 2 over 3. So again, is 7 over 9 equal to 2 over 3? Well, no. So this is going to be false. Okay. All right. Cool beans. All right. Any questions about that? No? Okay. We'll go ahead and move on. All right. Now, there is one more way here. Okay. Okay, so now there's one more way for us to go ahead and determine if a proportion is true. And probably, in my opinion, one of the easiest ways to determine this. So you can reduce fractions like this, and it does take a lot of work to do. Okay, but the most popular way, of course, is to cross multiply. Okay, so cross multiplication is one of those ways where you can certainly say, okay, you don't even have to reduce the fractions. You could be like, okay, I'm going to cross multiply. I'm going to see if they're equal to each other once I cross multiply, and then we'll be good to go. So it says using cross products. Again, you can call this cross multiplication or cross multiply. There's pretty common here. All right, so let's use cross multiplication to see if the proportion is true or false. Now, how does it work? We're not reducing any fractions. Okay, so let's put that as a note here. Okay, there's a note here. There's no need to reduce fractions. We're just going to work with the numbers here straight up as is. All right, that's it. So when we cross multiply, we go exactly what it says from cross. So again, if we look at the picture here, we go from the upper left-hand corner to the bottom right-hand corner. Like, again, just going diagonally. So we go 3 to 20. And again, a lot of people like to write arrows here, so that way they know which number is associated with which. And then 12 here goes with 5. So on the left-hand side here, I would have 12 times 5. Okay. And on the right-hand side, I would have 3 times 20. And then all I would have to do is go ahead and just multiply both the left-hand side and right-hand side and just check if they're equal. Well, if I do 12 times 5, that's 60. And if I do 3 times 20, that's also 60. So is this true? Well, yes, this is definitely true because both when we cross multiplied, both the left-hand side and right-hand side both equaled each other. So again, once again here, if the left-hand side equals the right-hand side, okay, then it's true. Where's this here? Okay. Okay, if the left-hand side does not equal the right-hand side, it's false. All right. Okay. All right. Now, let's do the next one here, and we'll see how we can tackle these problems as well. All right. So in this problem here, we're going to cross multiply these two numbers right here. We have 2 and a third and 3 and a third. So we got mixed numbers here in this case, okay? Let's see how we can tackle those here at least with the cross multiplication. So the first thing we'll do is we'll do 9 and 3 and a third equals 2 and a third times 16. So okay, by itself, that looks pretty straightforward, not too hard. Now, what we want to do next is, it's like, okay, well, how do I deal with a situation like this where you're like, it isn't so obvious if these two are equal to each other, or how can I even do that in, in an easier way? Well, again, what's the key here in a problem with mixed numbers? Let's go ahead and write that down. Yes, 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 yes. So the key here in a problem like this with mixed numbers is to, once again, change the mixed numbers into improper fractions. And then multiply. Okay, so we're going to do the same thing we've done pretty much for quite a while and say, okay, hey, we're going to change the mixed numbers into improper fractions and then multiply it together. So if I took a look here at this particular problem, I said, okay, well, what's 3 and a third? Well, 3 and a third as a mixed number, as an improper fraction, is going to be 3 times 3 is 9 plus 1 is 10, so 10 over 3. I haven't decided when the test is yet, but once we do finish Chapter 5, which will be the next section after Section 5.4, 5.5 is the last section for Chapter 5, then I'll announce a test there, Hannah. So you will definitely know well ahead of time, just as usual. No problem. So we're going to have 9 times 10 thirds. Remember that we have 2 and a third, by the way. Let's do 2 and a third here. 2 and a third is going to be 7 over 3. So we're going to have 7 over 3 times 16. Look, I know. Look at that. Look at that kit, man. Darn right. Thanks, man. Thanks, mate. I really appreciate that. Much love, man. Thank you, my friend. Thank you. You're very kind. You're very kind, LP. Oh man. Okay. Let's go ahead. Man. Uh, I gotta rock. I should have rocked the hashtag. I should have struck the hashtag kit yesterday, LP. I should have. But I decided to do it today. It was worth it. All right. Um, all right, so let's do 9 times 10 over 3. Okay. Whew. All right, so if we do 9 times 10 over 3, um, what can we do here in this case? Can we reduce anything down in 9 times 10 over 3? Okay, this. What can we reduce down here, everybody? I remember I could put 9 over 1 here. Okay, it's one of those things. You guys let me know. Can we reduce anything down? Is there any numbers in common between something in the numerator and denominator? All right, divide 3. This I agree with. So we have the 9 and the 3 here. Good. So we're going to go ahead and divide by 3 here. And we'll also divide by 3 here. So 9 divided by 3, it'll be 3 straight up. And here we have 3 divided by 3, that's 1. So here we're going to get 3 over 1 times 10 over 1. So on the left-hand side, we get 30. All right, so that's what we have here on the left-hand side. Left-hand side, we have 30. So if these two are equal to each other, on the right-hand side, I should also have 30 here. Okay, so let's see what we get here. Okay, so don't know yet, but we're going to find out. All right, so let's do the right-hand side here. 7 over 3 times 16. Okay, now let's answer this question here. Let's answer this question. Does 16 and 3 have something in common? Pretty much a yes or no question here. No, no, unfortunately not. So we're kind of out of luck here. We're like saying, all right, we want to be able to reduce it down, but just meh, too bad. So sadness. So let's let's go ahead and just multiply straight across like we normally do. So, okay, so again, that's the only thing we can do here. Okay, is just if we're going to test out, we're just going to see. Well, hey, let's multiply straight across and see what we get. We're still aiming for 30 here, so you don't know, but you kind of hope. So if you do 16 times 7 here, all right, so that's going to be 112. Okay, so again, you can do that out if you like. So we get 112 over 3. All right. Now, again, let's go ahead and change this back into a mixed number if necessary. So let's just see what we get here. So we got 3 and 112 here. So I'll give you a nice reminder about how to do that nice long division by hand. All right, 3 goes into not 1, but 3 definitely goes into 11 3 times. 3 times 3 is 9. We'll bring down the 2, and we'll bring down the next 2 here. 3 goes into 22 7 times. So we have 21, and in this case here, since we want a mixed number, we'll have the remainder of 1. So our answer here will be 37 and 1/3. All right, so here we have 30 on the left-hand side and 37 and a third on the right-hand side. So in this case here, the answer is false. Okay. So unfortunately for us, that does not work. They are definitely not equal to each other. Try as we might, too bad, so sad. All right. All right. Any questions about that? Any questions about that, anybody? Okay. I'll just assume we'll just, nope. Okay. No problem. All right. Now, I'm just going to have you guys do one of these problems here. Okay, so that way you'll have a chance to do that as well. Why don't you guys try a couple of these? I want you to try letter C. Okay. Try letter C and letter D. Okay, so letter C and letter D. Okay. Let's go ahead and take a couple minutes here. I want you to try letter C and letter D here. All right. Let's give it a go. Once you have answers for both C and D, go ahead and post that up in the chat. Again, just true or false for both. So All right. Let's take a look at letter C here. Does anybody have an answer for letter C? Took like a couple minutes there, so anybody got an answer here for letter C? That's okay. All right, so we're going to cross multiply here. All right. So here we have, we're going to have, again, on the left-hand side, we're going to have 17 times 20. On the right-hand side, we're going to have 10 times 34. Okay. So if we do 17 times 20, that's going to be 340. On the right-hand side, that will also be 340. Okay, so since these are both equal, this first one here is definitely true. Okay, so far so good. Let's look at the next one. We'll cross multiply here. So on the left side, we get 5 times 6. And on the right side, we get 2.4 times 12. So 5 times 6 is 30. 2.4 times 12 times 12. Is that 4.8 times 6? What is that off the top of my head? 288. So 28.88, right? 28.8. Okay. So here we get 28.8. Okay. So is 30 equal to 28.8? The answer is no. So this is false. All right. So C here is true and D here is false. Okay. Cool. Cool. Not too bad, Hannah? I hope not. Seems like you're picking up on this pretty good, so I'm pretty happy to see that. All right. Okay. Next, let's go into the next section here, which is section 5.4. All right. So section 5.4 here is solving proportions. Okay. So what we want to do here is we are going to pretty much do the same exact thing we did in just this last section we just talked about. There's only going to be one difference. The one difference here between this section and the previous section is now we're just missing a number. Okay, and we want to find that missing number here. Now we're going to find that missing number here and say we're going to find that missing number here, and typically those missing numbers are called a variable here. We call them x. Okay, so a lot of times you'll see x, like find x, okay, or find, you could call it any letter you want, but x is the most common one that you see quite often. Now the question is, well, what's the key to finding this x, okay? How do we do that? Let's talk about that here. The key is to go through a process here, okay? You're going to cross multiply. You're going to cross multiply and then use algebra. And I'll describe what the second key is here in just a second. But we're going to cross multiply here, and then we're going to use some algebra to solve for this x. So this here is really important because this is going to be our first instance of really using algebra outright. Like we've done it maybe a couple of times before, but now we actually are going to use it outright here in problems like these. Let's take a look at how we can do that here. So I'm going to go ahead and cross multiply this, just like so. And so here we're going to have 32 times x equals 16 times 20. Okay, that's what we have here so far. Okay, so we have 32 times x equals 16 times 20. Anybody tell me what is 16 times 20? Yeah. 320, good. 320, excellent. Now, let's talk about the next part here. So this is the big part. Where's this algebra part come into play? Okay, so this is going to be, again, one of the biggest keys, and I probably have talked about this before, but now you'll see the real kind of strength behind why I say it, right? Right, that is exactly correct. And the key that we're wanting to use here is, let's take a look at the key to algebra. I probably have said this before, the key to algebra is always one word. It is balance. Everything that you'll learn in algebra, I probably have said it before, and I'm probably reiterating it again, is everything in algebra to help you understand algebra always revolves around the word of balance. If you balance things out, good things happen, okay? So typically most concepts in algebra all revolve around this idea of balance. So if we have 32 times x, and I say I want to get x by itself, then Hannah's correct, and we divide by 32 here on to get rid of the 32 next to the x. But of course, we have to balance. So what we do on one side, in this case the left-hand side, we also have to do it on the right-hand side as well. So we get 32 on the, we have to divide by 32 on the right-hand side as well. So what we'll get here is we'll get 320 divided by 32. So as Hannah correctly says, x is equal to 10. Spot on. That's really the key behind finding the unknown quantity in any proportion. All right, is basically going to boil down to these two parts. And again, getting our good, kind of first look at, how we're using algebra here, you're going to take this idea of balance, you're going to use it over and over again in some capacity to solve for x or solve for variable or variables. All right, it will still be the same. And it's just like, okay, you're going boom, 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 just working out that balance in some way, shape, or form. Let's try this next one here. 7 over 15 equals 15 over x. Again, we're going to just cross multiply. So we'll have 15 times 12 equals 7 times x. What is 15 times 12? $180. Okay, good. So we take 180. We'll set that equal to 7x. Okay. And what do we get here in this case? What we have to do next, I should say. Sorry. Maybe I should do that first. Sorry. divide by 7. Okay, remember we divide by 7 here, and we divide by 7 here. So this gets to go away. So we have 180 over 7. Okay, let's go ahead and figure out what 180 divided by 7 is. So here we're just gonna maybe not super clear. So ew, come on, decimals are kind of important, you know. Gotta. I know it's not nice, clean numbers there, Hannah. I'm sorry. I'm sorry. Not everything gonna be nice and clean. Okay, but maybe we could do it with mixed numbers. How about that? A little bit nicer. Okay, a little bit nicer. So we could do like 2. 7 goes into 18 two times. It's gonna be 14. So if we subtract here, we get 4. Bring down the 0 here. 7 goes into 40 5 times. So 5 times here. And then we get 35. So here we get a remainder of 5. So it may not be the nicest decimal, but as a mixed number, I think that looks a bit better. So 25 and 5/7 would be our answer for this. Okay. Man. Yes, they are. How? How are decimals like bugs? Because they're nasty. Oh man. All right, let's have you guys try. Let's have you guys try one or a couple here. All right, let's try. Have you guys try letter B. Doesn't take. you're, you're fine, man. You're fine. Oh man, you guys are so crazy in the morning. It's amazing. Get 25 for that. Okay. All right, anyone else? Okay. All right, let's take a look at this one here. So I'm going to cross multiply here. So we got 10 times 15 on the left-hand side. No one else is, maybe. I know, maybe 9:30 is like the zombie time. I don't know. Maybe because everybody's been holed up inside their houses all day. It's like, yeah, super zombies, All right, here we go. 150 equals 6x. Divide by 6. And indeed, I agree. X is absolutely equal to 25. Okay. All right, good. So far, so bueno. Let's try another. All right. So let's try it with E. So let's take a minute to try E. We're going to get a mixed number here for this answer, so don't be surprised about that. All right, this one's maybe a little tough. That's okay. Let's give it a go. Yeah? All right. So on the left-hand side, we get 11x. On the right-hand side, we get 14 times 3. Now, so we have 11x equals 14 times 3, which is 42. Okay. We'll divide by 11. Okay. So we got 42 divided by 11. Now, 11 goes into 42 3 times. So here we get 42 minus 33, which is 9. Remember, that's a remainder of 9. So 3 and 9/11ths will be our final result here for this problem. Okay. Any Any questions about this example? So hopefully we got that going. All right. Seeing as nobody's alive, I'm just going to keep going. That's okay. Okay. Now, we'll do one more here with some decimals. Some of the decimals here are not too hard. Again, it's just a matter of all good in the hood. Very good. All right. So, like some of these problems here do have decimals, and they do have the expectation for us to go ahead and, find the decimal equivalent here. So, for example, letter D is a good example about where that is definitely the case. So, here in this case, again, you cross multiply here. We're going to get, like, say, 5 times 13 equals 2.2 times x. All right. So we get 5 times 13, which is 65, which equals 2.2x. Okay. Then we'll just divide by 2.2. And again, this one here probably would be a good calculator problem because 2.2 is kind of weird to do. It would probably take you a little time to get through. We're going to round to the nearest hundredth here. So remember, the nearest hundredth here are 2 decimal places. Okay, so we want 2 decimal places. Okay, so just to kind of showcase this one here, we'll do 65 divided by 2.2. All right, so on the calculator here, you're going to get 29.545. Now remember, if we're rounding to the nearest hundredth, okay, the nearest hundredth would mean this second decimal place. And we look at the, I want to circle this one. We'll underline this. We want to round this up to 5, and then this changes over to 0. So our answer here, if we round properly, is 29.55. Okay, so don't forget here, read the instructions carefully. Again, they will, some problems there, if you probably noticed for the homework, and for decimals especially, a lot of them do ask you to say, hey, can you round to these number of decimal places, or hey, can you round to the nearest hundredth, the nearest thousandth, the nearest whatever. Okay, so some of them are certainly going to have that put into play and have that go on. Okay. All right. Any questions about that? All right. That was the last example that I wanted to do because the others are pretty much similar. So, okay. So, that's the end of section 5.4. Gives you a brief synopsis here about how that works. Again, with mixed numbers here, you're doing the same thing, converting them into improper fractions, multiplying, doing the things. So it's not too bad. Okay, so that's going to take care of it for us here for today. All right, next time we're going to finish off here with chapter 5, all right, which is application problems with proportions. I know everybody doesn't like application problems, but we got to do them. All right, that's kind of a thing. All right. So we're going to wrap up chapter 5 here for next time, and then if we are able to wrap up with chapter 5, I'll be making an announcement in regards to the test here All right, next class on Tuesday. Okay? So we should be all right. Good. All right. So I want to thank everybody very much for coming out to the stream here once again. All right. Thank you. You have a great day, Hannah. Thanks everybody for coming out to the stream once again. If you're here for the 11 o'clock class, stick around. I'm going to keep the stream up here. Um, yeah, no problem. No problem. I'm more than happy to help. Yeah, but I'm going to keep the stream up here. I'm just going to kind of do the streams back to back, but I'll just keep it up here. So if you feel like if you want to step out, you can. I'm just going to leave it up here. I'll put on some anthem music. I think that's a good idea. We'll do this the right way. Okay, let's give it a shot, right? Have a great day, Alyssa. You have a wonderful day as well. Enjoy yourself for this weekend.
I never felt the way I do about anyone but you. If I were to lose you now, I don't know what I might do. You're in all of my dreams, whether I'm awake or I'm asleep. My love ain't going anywhere, babe. I'm in this way too deep. Yeah. It takes courage
Yeah, now you always have my support at any time. If you just need to talk, you know? Wow, that's pretty late. I thought they would have done that sooner. I really thought they would have done the hybrid stuff sooner, you know? Uh, I mean, at this point, you know, I think you have to go hybrid, partially online and partially in class. But you have to social distance the students. I mean, what else can you really do? You can't have, you know, 1,000+ students roaming the halls, you know? Gotta be, yeah, I see where the parents are coming from because they have to do work and jobs and stuff, and it's hard for them to balance out the kids who have to go to school and and them working because it's like two jobs at the same time. So it is a really big transition even for parents to understand, be like, yeah, there's kind of a lot to do if I have to teach my kid, but at the same time, do my work. So,
Computer says he's not set up properly. Oh my days. So it works there, but like chat, it's not loaded on my screen. I can't see it. These
ah,
lot can.
gotcha. That's how that works. Okay. Had to just check something. Oh man, that stinks. Ugh, yucko. Boo. Oh, that's no fun. Yeah, it's just way too much to handle. I mean, that's the point I could make. It's basically you just had red tape and then you just added more red tape on top of the red tape that they were already there. Yeah, so if there's one thing that's a little tough in the United States compared to other countries, reasonably, is that it's very the infrastructure for the internet is not as good as it can be. Again, though, a lot of that has to do with just the size of size of the U.S. in general. That happens to be just very large, and putting down that much infrastructure is very, very difficult and very expensive. So, I mean, to be fair, that's just how it is. So, wish we could kind of be like, South Korea and be like, oh yeah, let's just throw a bunch of, let's make it like super, 5 gigas bit speed fast or something like that. So, sadly, we don't get that option, but still. Yeah, that's why I didn't choose to become a high school teacher. I could have gone through the program because I was accepted into the program to get certified as a high school teacher, and I didn't do it because I was like, I don't want to go through like 5,000 yards of red tape. I said I want to be able to talk to students face to face. I want to be able to not have to jump through hoops. I want to just be able to say, hey, let's talk what's going on. Let's discuss about it. Let's do something about it. I I'm more of an action and be like, hey, let's take some actions to help you during these rough times. You know, I remember how valuable that was when I talked to my high school counselor uh, back in the day. And how important it was just to have those conversations and try and get me through tough situations and stuff like that. It was very valuable. And the bad part was there's only one high school like counselor, so I'm like, there definitely needs to be like more people to talk to like students. Yeah, it is. It's not a situation that anybody would find the best, obviously. I don't disagree with that. Yeah, teaching is gonna be, teaching is tough, but it's you gotta push on through. You may not like it, but we play a vital role. You have to be there for the people who are going to struggle during these times. Who are going to be stuck in environments they may not want to be in 24/7. We got to be there for them. Be something that they can hold on to. Very important. Thanks, Anna. I appreciate you. All right. Okay. Let's see who else is in here. I gotta see here. Who's ready for some math? Who's ready for some math? Ready for some class? I see Sion. Sion's in here. That's good. Hello, Sion. Poggers for math. Heck yeah. I'm down for that. Boom. I'm doing well, Sion. I hope you're doing well. There you go. Random emotes are random. But they actually have meaning. Here you go. Okay. Good, 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 good. All right. So looks like we're ready to go. I think most people are starting to trickle in here, so we'll probably go ahead and get started. All right, let's do this. Yes. All right. Okay, let's get started today. Welcome back to Thursday, end of the week time today. This is the only time we're meeting this week. Last time we didn't get a chance to meet on Tuesday due to it being election day. So I hope you went out and voted, had a sit and chill time. Hello, Patricia. I hope you're having a great day. Like I said in the first class was a little more quiet. I know you guys aren't, but it's like you got the good vibes going today. Okay, you got the good vibes going today. All right, good vibes today. Okay, everybody, good vibes. Okay, somehow you can just feel it. Carissa, good morning. Good morning. How are you? We could all feel the good vibes today. I could just feel it pool in me. Okay, very important. Very important. Okay, cool. All right, let's do this. All right. So, just to give you a heads up here, just want to recap here for just a second. Today we're going to be doing sections 5.3 and 5.4. So, for those of you who ask typically for the homework stuff there, so sections 5.3 and 5.4 are what's on the agenda here for today. Now, section 5.5 here is going to be the last section here, I believe, of chapter 5. The next test is going to cover both chapters 4 and 5. So once we're done with chapter 5 here in the next section, which will be on next week on Tuesday, I'll be probably announcing a test right around that time. Okay, so once again, of course, I'm going to give you a fair warning, usually a week ahead of time sort of thing to do the test and whatnot. All right, but that's what I'm aiming for anyway at this point. Okay, so that's what's on the agenda here for what's upcoming here for this today and next week. So got all that on the docket here, so we should be good to go. Are there any questions? Yes, I need my crocodile fan fact of the day. This is important. I'm gonna look that up. That is actually really interesting. Um, Orinoco. Orinoco. Okay, gotcha. Daniel's got all the crocodile and alligator facts. He's my dude. All right. Okay. Does anybody have any questions about anything from last week, or again from for the past week? Any questions at all? No pope 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 pope. Okay. Lovely. I love my lack of connection. It's terrible. All right. Okay. None from you? Okay. That's fine. All right, so there'll be a bit of a lag here, but I mean, it is what it is. So we skipped the sixes. You mean chapter six? Samantha? Hey, he's how are you? No, we haven't skipped chapter six. Okay. All right. Okay, so let's go ahead and get going here. All right, so for today, I'm doing well, he said. I'm doing well. If I could ever get this darn thing to work, work, darn you, work. I demand that you work, please. Okay. This thing never wants to work the way I want it to. Anyway, I'll figure that out later. All right. So today we're going to be talking about proportions. I'm doing really good, he said, by the way. All right. So let's talk about proportions here. We're going to talk about how to write out proportions here. We're going to talk about how to solve for proportions here today. That's what we're going to be doing here in these next two sections. Okay. So let's go ahead and do this out here. So writing out proportions here is going to look, we're going to use the same template here pretty much if we want to write out proportions. Okay, so how do we exactly do that here? Well, first thing that we're going to do here is a proportion looks like this. Again, we have, say, sum A over B is equal to C over D. Okay, something to that effect. All right, so A over B is equal to C over D, and there we go. Not too bad. All right, now the question is, how do we know how to write out proportions based on the wording? So let's say we want to say we have 6 feet is to 11 feet as 18 feet is to 33 feet. So what we're going to do here is we're going to split this off here just like so. Okay, so we'll have 6 feet is to 11 feet and 18 feet is to 33 feet. So if we want to do this out here appropriately, all right, let's talk about the key here in this particular case. The key here is to make sure to line up your respective units. Okay? So make sure to line up your respective units. Now you're probably saying, whoa, 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 time out. What does that mean? Okay. So let's take a look here and see which numbers go in which spots based on what a proportion generically looks like. Well, it says here first, 6 feet is to 11 feet. So if 6 feet is here to 11 feet, then we're going to put 6 feet here to start with, is to 11 feet. So we're basically going to put them on the same line, okay? So when I say line up, that is the key thing here. We want to line it up. So again, 6 feet is equal to this 11 feet here. And then as would be kind of like that equal sign here. You could also say is the equal sign. 6 equals 11. as 18 feet is to 33 feet. So 18 feet here lines up exactly with 33 feet here, and they're both here in the bottom part here of each respective proportion. Okay, so that's how we can go ahead and attack these kind of problems here, all right, and be able to do these out. Okay, so that shouldn't be too bad there, no problems. Okay, now of course that one's not too easy, so that's fair. Let's take a look here at letter B. Let's see if we can write this out, okay, using our lining up our respective units here. So it says $9 is to 6 liters as $3 is to 2 liters. So what we're going to have here is we're going to have $9 here to start with. You know, you could just build it like this. Just have another line on the other side if you want. $9 lines should line up exactly with 6 liters. Okay, just like so. And what should I put below 9? Should I put the $3 or should I put the 2? What should I put below 9 here? The $9. All right, $3. All right. That's right. I should put the 3, definitely. And so here we have 2 liters right on the bottom here. Again, just lining them up exactly. All right. And that's how we can write out a proportion based on the wording. Okay, let's have you guys give it a quick try here. Let's go ahead and take a look at letter A. We'll spend like 30 seconds to a minute to this problem here. So again, you could write that out in the chat once you have an answer here. $7 is to 3 cans is $28 is to 12 cans. So let's give you a minute to hopefully do that one out. All right. Yeah, hopefully it didn't take you too long. Good, good. I see all the good answers in there. All the super bueno stuff. Okay, all of this I agree with. All right, so $7 goes to 3 cans. Yep, spot on, Robert. Hey, Robert, I didn't see you there, buddy. How are you doing? Samantha, good job. How you doing today? Okay. All right, good. Everybody got it right. So 7 over 28 there respectively, and 3 cans over 12 cans. Perfect. Nice work. All right, so that isn't too hard. I think everybody picked up on that rather quick. Again, just lining it up and making sure we have our respective units. I'm doing very good. I was just surprised you didn't say good morning. I'm like, dude, you know? I was like, dude, what's going on here, you know? I was really worried about you there, Robert. You know, scare me like that. Here we go. I think that's a bit better. There we are. Perfect. All right. Make sure to take that off. All right. All is good. All is good. That's good to hear, my dude. All right. Let's take a good look here. Let's take a good look here uh, at writing ratios here in lowest terms. So what we were trying to do here is we're trying to determine whether each ratio here is true or false by writing both ratios in lowest terms. So all we're going to do is what we want to have happen is we want the left-hand side to equal the right-hand side here. Okay, that's what we want to have happen. And the only way we can determine if the left-hand side equals the right-hand side is if they are the exact same fraction after reducing it down. So we're going to have to divide the numerator and denominator by some numbers to reduce it down until we get to till we cannot do no more. So let's take a look at this first example here. Here we see 5 over 9. Now 5 over 9 by itself, we can't really do much with because 5 and 9, they don't have a common factor. So unfortunately, we can't divide anything out, and that'll just be just like that. Next, we'll have 18 over 27. I think we can reduce something there. What can we divide on the numerator and denominator here to reduce that fraction down? 7? 7 doesn't divide 18 or 27. Says 7? I could divide 3. I mean, that's true. 3? Yeah, I could divide 3 there. Oh, it's like 3 is correct. Okay, good. So we got 6 and 9. Can we reduce that down further? I agree with 3. Everybody's right with the 3 there. Okay, we can divide by 3 one more time. Okay, so again, you keep reducing until you can do no more. 2/3, that's correct. So as we see here, we have 5/9 and we on the left side, and we got 2/3 on the right hand side. So 5/9 equals to 2/3. Well, that's definitely a no. They're definitely not equal to each other. So the answer is false. Okay, that is completely false. All right, any questions about that? Daniel's like, yeah, 7. I'm like, heh, 7? No, okay. No. You're gonna scare me like that. All right. All right, let's have you guys try one here. You guys are pretty good. Actually, you know what? No, we'll do. You guys try letter B. You guys are on the ball today. You guys try letter B. All right. And we'll see if that's true or false. Once you figure out it's true or false, so go ahead and type that answer in the chat. Why did I say it was false? Because these two fractions are not equal to each other, right? 5/9 does not equal 2/3. Right? I need the left-hand side equal the right-hand side. That's why I said it was false. So if left-hand side's, so oh well, yeah. Let me zoom this up here. So if the left-hand side equals the right-hand side, then it's true. Yeah. If they don't equal to each other, false. Okay. So let's have you guys try letter B. You can tell me if it is true or false, and then we'll go ahead and do it together. Let's take a minute to do that one. So that's true. Okay. True dat. True dat, yo. All right. Let's find out if it's true. I have a feeling you all are all correct here. So we're going to divide by 4 here for this first one. So that's 4/3. I agree with that. And then since, we have 28 over 21. And this is definitely, as you mentioned here, Daniel, is like you divide by 7 here. And we do get 4/3 here. So 4/3 equals 4/3. So I agree with everybody. This is true. Good beans. Nice job, everybody. Very good. All right. Easy peasy, lemon squeezy. Okay. Okay. Questions about that? No? Okay. Let's go ahead, and you guys are doing super good. So I'm actually going to do one less example there, and do more examples at the end. So for the tougher stuff. So, okay, let's go to the next part here. Now there's an easier way to figure out if two fractions are going to a proportion are equal to each other, and that is with the most common method here. And the most common method here is cross multiplication. Now they do say cross product here, but cross multiplication, as you can see here via the picture, again, you go say from top left to bottom right, or again from top right to bottom left. Okay, so you can cross multiply here. Now I like to actually draw the arrows both going down. There's a particular reason for that. The reason why I do it that way, as opposed to what the book says, is because then they just kind of I can see the number from top to bottom and trickle down. It's a little bit easier that way, in my opinion. But that's just my opinion. All right. In any case, we're going to be using cross multiplication. Okay. So this is AKA cross multiplication. So I'm going to be often saying cross multiply, but it's just a commonly used term as well. So let's see if the proportions are true or false. And we're going to talk about a couple of these examples here. So how does it work? Well, 3/5 equals 12 over 20. All right, let's see if these two proportions are indeed equal to each other. Now, one of the things that I want to state here is, and let's make a note about this, is you do not need to reduce fractions. Okay, so that's one very big benefit here for this process is there's no need for you to go ahead and reduce any fractions down. All right, it's all about, hey, we can just take the numbers straight up and we could just take a look and say, all right, left-hand side equals right-hand side once again, and we're done. Okay, so we don't have to go through painstaking processes if the numbers are more complicated than maybe what you see here in letter A, such as letter B with like mixed numbers. I don't think we want to really guess. I think we actually want to just use the numbers straight up as is. So here we have 3 and 20 cross, and then we'll cross here. So here we have 5, we have a, oops, I wanted to, not that, sorry. So here we get 12 times 5 equals 3 times 20. And all we have to do is look at the left-hand side and the right-hand side. So 12 times 5, 60. 3 times 20, also 60. So I could say these proportions here are definite true. Okay, without question. Just do that multiplication, and there we go. We got it. All right, no problem. Okay, that part there I don't think is too hard. Now let's talk about other situations though. And letter B is another good classic situation which we could run into in terms of saying what happens if we end up with mixed numbers as opposed to just nice clean numbers. Okay, exactly how do we deal with something like that? So let's talk about the key behind this problem here. And the key is going to be pretty much the same as what we've been doing with mixed numbers this whole time, is you're going to change the mixed number or numbers into improper fractions first. Okay, and and then multiply. So the key thing is that we want to change our mixed numbers into improper fractions first, and then we're just going to do our cross multiplication, see what we need to multiply by, and hopefully find our answer. So let's go ahead and try it out for this problem here. So here we have 9 times 3 1/3 equals 2 1/3 times 16. Okay, so on the surface, you're not sure what this exactly is going to look like, what both sides will look like, but what you do know for a fact here is that, we got 9 times 3 1/3 may not be super easy to see, but we'll find out. Now, let's change 3 1/3 here into a improper fraction. Anybody tell me here, what's 3 1/3 as an improper fraction? Ten-thirds. Okay, good. That's right. And how about 2 1/3? All right, 7/3. Good. All right. Excellent. So here we have 9 times 10/3, and that should equal 7/3 times 16. So remember how it works for multiplication. We want to just check to see if we can reduce anything down. So remember, we can write 9 as 9/1 and 16 as 16/1. Okay. So is there anything on the left-hand side there that we can reduce down before we multiply? What do we see on the left-hand side? 9 and 3 are divisible by 3. That's correct. Okay, good. So I'm going to divide straight up by 3. So we get 9 divided by 3, which is 3. 3 divided by 3, which is 1. So we get 3/1 times 10/1, which equals 30. So we get 30 there for the first one. Let's look at the second one. How about the right-hand side? Anything that we can reduce? Okay. Doesn't look like it, right? 16 doesn't go into 3? Yeah. Yeah, so I said you do not need to reduce? Not in every case, no. I'm not reducing the fractions in this case. What I'm doing is I'm multiplying, but remember how we did fraction multiplication, Samantha? We did reduce it to make sure we get smaller numbers, so that way when we put it together, it makes it easier just to multiply it together. So It just takes less work in that regard. So I'm not reducing the fractions here in this case. What I am doing though is just for fraction multiplication, that was part of our processes to reduce things down. When I was talking about reducing fractions here, I was talking about just the starting problem there. I guess that was the distinction there. 16? Yeah, 16 and 3, they're not good friends. They're actually bad friends. So unfortunately for us here on this right-hand side, that's kind of a unfortunate no-go zone in terms of reduction of anything. So we have 7 times 16 here, which is 112 over 3. And let's see what we get here for 112 over 3. Maybe, our goal here is to get 30. So this is 2. This is 2. Okay, so we have 3 goes into 22 7 times. So that's 21. So that gives us a remainder of 1. So we have 37 and 1/3. So again, we take a look here. 30 equals 37 and 1/3. Yeah, no, unfortunately. So in this case here, this would be false as a result. Okay, any questions about that? Okay. All right, good. Samantha, does that explanation make sense? Does it make sense to you now? I just want to be sure that you understood what I meant by reduction for fraction multiplication. No, you didn't understand that? So, okay. So basically my point is this. I basically said this note here when I said do not need to reduce fractions. This was more in lines of the fact that I'll put this here. This is reducing fractions on the left-hand side or right-hand side at the beginning of the problem. So in this process here, I just more meant it as a way of saying, okay, I don't need to reduce 12 over 20. I'm just going to go with the regular numbers that I'm given here and then just cross multiply. Okay, that's basically what I was trying to say there. Whereas in this process, we already had cross multiplied, and then I wanted to multiply 9 times 3 1/3, and basically that just reduced down to fraction multiplication. And to make fraction multiplication easy on ourselves, I went ahead and just reduced it down, so that way I reduced it in the middle of this process here so I could see what I got. I would get 30 here in this case. So I didn't reduce the fraction because I had already cross multiplied here, whereas I was referring to the start of the problem here in this case. Is that hopefully a little bit okay? So that I just want to clear that. I just want to clear that up there so it makes more sense why I did it in the middle of this problem, but I didn't do it here. Was simply because I'm just referring to the beginning of the problem here. After you cross multiply, all bets are off. So All right, let's try another one here. Let's have you guys give it a try. Okay. So we're going to test to see if it's true or false. Let's have you guys try letter B. Let's have you try letter B right there. And I'll have you try one more here as well. Let's have you try letter D. Letter B and letter D. Okay, no problem. Cool. Glad that makes more sense. Yep, spot on. Thirty-two, 30 not equal. Okay. Say there's okay, so you see say B is not equal here. All right. Or it's D, sorry. Or not, well maybe not D, but okay. Okay. So that's what Sion got there. All right. Both are false. Okay. Anybody else? All right. So let's look at 32 over 15 and 16 over 8. All right. So let's go ahead and cross multiply here. So here we get 15. Actually, sorry. Here we get 16 times 15 equals 32 times 8. So over here, 16 times 15 is 240. 32 times 8 is 256. So indeed, this is false. Okay, they are definitely not equal to each other. So absolutely true, 100%. All right, and we also have this one here. We'll cross multiply here. So we have 5 times 6 equals 2.4 times 12. Oh. All right, so in this case here, 5 times 6 times, anytime now, is 30, and 22.4 times 1.2, times 12, sorry, is 28.8. So this 2 is also false. Good. Nice job, everybody. All right. Questions about that? Bleh. If I could speak, I'll let you know. Nope. Nope. All right. The rest of the problems here are just pretty much similar to what we just talked about. Okay. Next. Next, we're going to be talking about solving proportions. Okay. So now the only difference between this section and this last section we just finished is now we're just trying to solve for an unknown quantity. In this case here, that unknown quantity is typically called x, okay? So you probably have seen this before. But this is really basically going to boil down to two important things. This is kind of like we've actually worked with this already just a little bit. But now we're really going to be working with a little bit more the taste of algebra here in this particular section. Okay, so the process is going to be pretty much the same. So it's like if we have this and say, hey, I want to find this unknown number. So it says 16 over x equals 32 over 20. So we're going to use cross multiplication here, just like we did in the last section. But we're also going to use a little bit of algebra. So let's talk about the key here. The key here is to cross multiply and use algebra to solve for x. Okay, that's the key that we're going to be using in this case. So let's go ahead and show off exactly how that's going to look like. In this case, we're going to have 16 times 20, 32 and x, okay? So we have 32 times x. So we're going to write that as 32x equals 16 times 20. All right. So what is 16 times 20? What's that going to be? $320. Good. Excellent. And we have a 32x here on the other side. Okay, now I want to be able to solve for x. So what should I do next? Okay, divide by 32. Okay. All right, so I see divide by 32, divide by 32x. All right. Now I agree we have to divide by 32, but let's discuss this particular part here. Okay. Times 32? We don't need to talk about that. Well, we'll see exactly why it's divide 32 here instead of times 32. Now, I want to showcase like why the algebra here is important. Now, we haven't talked about a lot of algebra here in this class. I know this is a pre-algebra class, but I want to actually kind of drill something into your head here because you're going to be using this concept I'll talk about here a lot of times. I probably have already mentioned it this semester at some point as well. So let's talk about the key to algebra here. And the key to algebra, as probably I've stated before, but if not, I'll state it here for the first time, is always coming down to the word balance. Remember what our goal is here. Our goal is here to get x by itself, okay? Right now, as it stands, you have 32 times x written right here. Okay, so we have 32 times x, but what it means is that if we want to get rid of the roadblock that is 32 times x, we do the opposite of multiplication in order to do so, which is divide by 32. Okay, so that's number one, why we want to divide by 32. Secondly, the reason why we don't divide by x is because we want to have x on the left-hand side. So that's why I'm not dividing by 32x, I'm just dividing by 32. Okay, I want to just have x on one side. X equals some number. But because of the word balance, okay, because of the word balance, what I do on one side is what I have to do on the other side. So I need to divide this by 32 as well, okay? So now I have the 32s, they'll wipe themselves out. Here I'm left with x on the left-hand side, and 320 divided by 32. And what's that going to be? $10. Perfect. Okay, so you guys could see how we got to that result there. Okay, again, dividing by that value on both sides there. Okay. Is there any questions about that one? Again, this is going to be for every problem in this section is going to boil down to pretty much what I've just shown you. There are some key differences in a few problems though. Letter B is another key difference here. We're going to go ahead and repeat the process for cross multiplying our numbers. So here we got 12 times 15 here is equal to 7x. All right. Now, in this case, let's take 12 times 15. All right. So that's going to be, what's 12 times 15 here? 180. Good. Now, our answer here is equal to 7x. All right. What do I do next? That's correct, Sion. What should I have here? What should I do next? Divide both sides by 7. Good. Now remember, our answer here may not be a clean number. Okay, so 180 divided by 7 may not divide cleanly. So you'll have to possibly put your answer there in mixed number format or in decimal format, depending on what the homework asks you or the test asks you. So the test says, hey, I want it in decimal. Okay, we'll put it in decimal. If it's test says, hey, I want it in mixed number format, then you put it in mixed number format. Just depends. So we'll go ahead and figure out what 180 divided by 7 is. Hopefully this will give you a good refresher about how to do this. So here we have 7 goes into, not into 1, but goes into 18 2 times. We're going to have 40. 7 goes into 40 5 times. Is this from Algebra 1? Yes, actually it is. This is one of those concepts from Algebra 1, yes. Good. Then it should be definitely helpful. Again, even if you struggle with algebra, if you remember that word balance, it really helps out a lot. So we get 5 here, 35. We'll go with remainder of 5 here. So we have 25 and 5/7 will be our answer for this problem. Okay. Good. All right. Any questions about that one? Nope. All right. Let's have you guys give one a try. Okay. Which one? Yes. Let's have you do this one. Let's have you do letter E. All right. So can you do letter E for me there? Again, you might get a mixed number for this, but that's okay. We'll take a minute and post in the chat once you have an answer for X. Okay. Okay. 3 and 9/11ths. All right. Anyone else? All right. 3 and 9/11ths. All right. Let's check it out. See if both of you, your answers there are spot on. So here we got 11x equals 14 times 3. Now if you do 14 times 3 here, that's going to be 42. Okay, good, good. A equals divided by 11 here. Let's check out 42 divided by 11. 11 goes into 42 3 times. Get 33 here. We get a remainder of 9. So all of you are correct here. 3 and 9/11ths here is the correct answer. Yes! Okay, great. Nice job, everybody. Very, very good. Very, very good. Any questions about that? That one there. All right. Let me see if they picked one here. Okay, right. Okay. Next is some other problems here. Now, one thing that I told you to be careful about is sometimes in the instructions here they ask you to say, in this case, round to the hundredths. Okay. Remember that hundredths here means 2 decimal places. Okay. So what we're going to do here specifically is to go ahead and just well, let's see, which one do I want to do here specifically? I know which one I did last time, but not that one. Ugh and yuck. Yeah, let's have you guys do letter D. Let's have you guys do letter D here first. So let's take another minute here. Try letter D and solve for x here, okay? Oh, yeah, I put up I don't know if you saw my video there about ECC having no classes on that day. Okay, we get to 29.55. 29.54. All right, now let's take a look here and which one of these is correct, because one of them definitely is. So if we cross multiply here, here we get 13 times 5 equals, we're on unit 5.4, my friend. 13 times 5 equals 2.2 times x. So here we get 65 equals 2.2 x. Divide by 2.2 here. Now, in this particular case here, this one, yeah, you could do this by hand, or you could do this on your calculator there. Now, what we get here after doing that division is you get 29.545. And again, because we're rounding to the nearest hundredth, 2 decimal places, we're rounding where you want to round to this number here. So we look to the right here, and since we have a 5 next to that 4, we're going to round that 4 up to a 5. And this 5 here has to change to a 0, obviously. So here we actually get 29.55 in this instance, okay? So you got to be a little careful about the rounding there, but 29.55 is actually going to be our answer for this problem. All right. No problem. Any questions about that one? Now you'll notice here you have mixed numbers. You're going to do the same thing you did the last section, just change the mixed numbers to improper fractions, then go ahead and cross multiply and do what you need to do. So let's have you do, that first one there, letter A. So this will be our last example here for this one. So let's have you try letter A here. Take a minute or two to get that done. Oh, okay, got it. Okay, so that's 13. All right. Anyone else? Anybody else? All right. Let's find out if 13 is indeed the answer here. Let's give it a try. Looks like a few people having a little tough time. So let's go ahead and see. All right. So first of all, before we start the problem, we're going to change up 3 and a fourth here into 13 over 4. That is the improper fraction there for that case. So what we have here is we have 13 over 4 over 2 equals x over 8. And now we'll go ahead and cross multiply that. So what we have here is we have 2x equals 13 over 4 times 8. Okay. Now remember that 8 can be written as 8 over 1, and 8 and 4 can be reduced. So we can divide this by 4, and we can divide this by 4 as well. This becomes 1, and this becomes 2. So here we have 2x equals 13 times 2. So if we do that, we have 2x here equals 26. Then divide by 2 here. So x here is equal to, indeed, 13. Very nice. Okay, good. Any questions about that? No? All right. Easy peasy. All right, great. Okay, so that's all I have for here for you for today. Okay, next time we're going to be going over, like I mentioned here, word problems on proportions. Okay, so word problems on proportions. I know everybody hates word problems, but we got to do them eventually. So we'll be going over word problems on proportions. All right, so that'll be the last section there of chapter 5. And we get finished through that here for next time. Then, of course, I'll be announcing the test. Okay, so for chapters 4 and 5 in this case. Okay, so both chapters there will be up for the test. Once I make an announcement, though, I'll probably be due the following week. So, just pretty much the usual. All right. All right. Very good. Great work, everybody, here today. I really, 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 really appreciate the time and effort you guys make to come out to my streams. You guys are really cool. All right, really awesome. All right, I really appreciate it very much. Yeah, you too. I want everybody to enjoy their weekend as much as possible. Okay, it looks very nice out. Okay, so go out for a walk, at least get out of your house, go do something different. All right, everyone, please enjoy the rest of your day. All right, and we'll go out with I'll go out with let's see, I'm gonna pick a different song this time. So yeah, let's do this. Let's I got some music to go out to. Get this one. Yeah, class. Yeah, class is over, but you're free. Have a great weekend, my friend. Oh, okay. Oh, okay. I got you, Sam. All right. So the way to do this is you would have you'd hit the fraction key and you put like 90 and then 150 on the bottom. Then you hit equals because we have to put equals in between both of those fractions. And then you would hit the fraction key again. And then you'd have 15 and 25. Like uh like that one there. Yeah, I'll tell you that. So don't forget the equal sign in between. Maybe that was the bigger issue. But yeah, you can hit that button twice. Oh boy. Any other questions there for me? No? Okay. No problem. Okay, cool. All right. Have yourself a wonderful weekend, okay? All right, we'll see you Tuesday. All right, everybody. If there anybody else have any more questions, otherwise, I'm going to head on out. Okay. All right, very good. I wish everybody a wonderful and happy and safe weekend. Stay safe, stay healthy, stay sane. All right? And we'll get through this together. Have a great weekend, everybody, and we'll see you later. All right, everybody. Take care of yourselves. All right. Bye.